Professor in 3D Geoinformation at TU Delft. She combines her professorship with a job as an innovation consultant at Cadastre, and I'm really excited to hear about digital twins, a comprehensive solution or a hopeful vision. Jantien.
Good morning, everybody. Yeah, so thank you for the introduction. And the title of my presentation is a question. Digital twin, is it a comprehensive solution or too promising concept? And I hope that after my talk you might have the answer, which is not black and white. As Anders also mentioned, digital twins, it's a quite broad concept. And if you Google on it, there are lots of digital twins out there. And they have many different appearances. So sometimes it's meant like an urban data model. Sometimes it's meant as an ecosystem of digital twins of different assets. Sometimes it's a digital model of one asset. Sometimes a 3D city model is considered a digital twin. And yeah, as we know, it's originated in industry, and in industry it is a digital counterpart of a product with real-time reflection of the physical space and the virtual space. You can interact with the digital model, and it includes historical and real-time data so that it continuously adapts to the real-time, the reality counterpart. In our geospatial domain, we don't have a harmonized definition of a digital twin, but we have more or less consensus of what it is. Also, as Anders explained, here they have their own definition, but there are many different definitions around there. But the main principle of a digital twin is that it's a digital model of the current state of reality. Yeah, it is more or less based on 3D city models with semantic data, so with objects in it, with real-time sensor data, so that the virtual copy can be updated and you can run simulations on the virtual copy to analyze different scenarios. And also visualization is a very important part of the digital twin, so that you can see what's currently happening in reality, but that you can also visualize the outcomes of what-if scenarios, and so that you can directly see what the impact is of an intervention. So digital twin is a very highly promising technique to solve global problems, and we have many global problems right now to solve, like climate adaptation, energy transition, mobility. So what are the challenges to make these promises a reality? It sounds so easy, and also if you looked at the movie, with which the conference started today, it's really promising what digital twins can bring us. But there are still challenges to make these promises a reality, and I have collected 7 challenges that needs to be addressed to make these promises a reality. So the first one is that I think it is a problem that digital twin is a very broad term. Because it's a catch-all term in which many remaining problems still fit. So we have had similar concepts that also addresses similar challenges like GIS, GeoBIM, smart cities, spatial data infrastructures, Internet of Things. And what we see is that those initiatives and those research areas, they solved the data sharing within individual projects, but what we see that it's still quite hard to share data across domains and to exchange data without any technical and without any non-technical restriction. So I think the risk of this broad term is that people can focus, also researchers, I'm a researcher myself, so I have also to blame myself, that you can say, okay, we developed a digital twin solution while you focus on the very technical aspects, for example, and you can ignore the less visible fundamental issues like to make sure that the project results also still work after the project has finished, or that it does not only work on a test area, but that it works on a larger area in reality. This is the first challenge for digital twin implementation in reality. Then the exact mirror concept of a digital twin sounds very nice, but also here there are some critical notes to make. So this exact mirror concept works for a single product which can be isolated from its surroundings, like a plane or a car. But if we look at our urban complexity, then this is much more challenging. So in the geospatial domain, we teach our students that models, spatial models, are always abstraction of reality. So it's not a one-to-one model of reality. So we make choices on what objects we collect and what attributes we collect. And also different applications need different data views on reality, on the same reality. So we have different digital twins addressing the needs of different applications. An illustrative example is the difference between BIM and geo. So I don't know if you're aware of the challenges of the integration between the geo world and the BIM world. So they model more or less similar concept, like a building, but a building in the design and construction process is completely different than a building in a planning process. And you need different views on this. And if you have tried to integrate a BIM model which is very high detailed and contains lots of structural elements information, if you try to convert that to a geo concept like a building with only the outer surface, for example, then you know how challenging this is. So the challenge here is how to translate the one-to-one expectations that there are about digital twins, how to change that and to make this people aware that it's about the multi-scale fit-for-purpose data, and then maybe also a metaphor of one overarching digital twin that solves all our problems is not very realistic. So in Dutch we have a word for a litter of digital twins. It's called meerling. I looked in the Swedish language, but I couldn't find an equivalent. Maybe there is one. But yeah, there is one. Okay. But I think the digital twin metaphor is not sufficient to describe this aspect of digital twin. So the challenge here is also how to implement the multi-view digital twin concept in practice. Then about temporal data. So we would like to have real-time data in the digital twin so that the virtual copy reflects reality. But then the question is, what is real-time data if you collect data from reality? So in the geospatial domain, if you have an actuality of a few days or a few weeks, that is already a high actuality. So what is real time, and do we really want to capture real-time data about everything? So the question here is how real-time is real-time, and what do we need to address the global challenges? But also how do we manage and maintain all those real-time data which becomes historical data? So the data of today is historical data tomorrow. So how to synchronize all this temporal data. And also, if you have different digital twins, then those digital twins have their own time paths and workflows. And it is easy to, it is already challenging maybe to integrate data from different sources at one timestamp. But those digital twins, they have their own life cycles. So how to make sure that they are synchronized in time and not only at one timestamp. And also versioning, so the management of different versions of digital twin it's still quite a challenge. Then about simulation. So this is also a very important principle of digital twins, that we can do simulations on noise, on energy consumption, on heat stress, so that we can directly see the impact of interventions. But with simulations, we have to be aware that they are developed in specific domains. And they have often a very specific hardware on which they can run. So it's not so easy to run simulations in one environment or on the same digital twin. And also it requires expert knowledge to understand the outcomes of simulations. So the questions and the challenges for simulations are how to feed different simulations that run in their own isolated software on their own data structures, for example, computer fluid dynamics, how to feed those simulations with the same digital twin version. And also how to integrate and balance the heterogeneous outcomes from different simulations and from different domains in one environment so that you can balance the outcomes against each other. So what is the best intervention if you look at all the aspects to be considered? How to keep the historical simulation outcomes available so that you can also go back to the data on which a specific decision was made, and that can also be a source for knowledge in the future. So to understand how the intervention did, how that developed when it was implemented in reality. And then another important aspect of simulation is the uncertainty that always goes with simulation. So I'm sure that there are simulation experts here in the room, and I think they know very well, and they are aware, and even they accept that there is always an uncertainty in simulations because you simplify reality. You have to simplify reality because otherwise simulations are not possible. Also, simulations are focused on a very specific phenomena. So how can you expose this aspect, this uncertainty aspects, to laymen who may be who made their decisions based on a dashboard with simulation outcomes? So how can people understand those uncertainty aspects to make their decisions? The fifth challenge is about visualization of digital twins. And the issue here is about realism versus realistic. Often it is assumed that the more realistic a model looks like, the better it is. And that is specifically for people who are maybe not so technically skilled. But still, realistic looking models cannot be the best models because they can be outdated. They can contain errors. They can also be less or equally accurate as less than models at a less level of detail. And also realistic-looking models, it's quite expensive to collect them and to keep them up to date. And also, many simulations, they cannot run on very highly detailed models, so they need generalization versions of the highly detailed digital twins. So the question here is how to deal with different levels of detail of digital twins for different needs and how to align them. And also how to prevent the overvaluation of realism and the undervaluation of data quality. So I'm happy that you also mentioned it as one of the challenges of future digital twins. That if you work with data, and that is the principle of digital twin, then you have to be aware that it's always, it's not working on reality. You work on data. Data contain errors. Data, as I said, is a selection of reality. So this has to be exposed somehow in the digital twin. Also, maybe an illustrative example is the smoothing of hooked contour lines. So the contour lines are generated from individual observation points, and the hooked contour lines, they are more in line with reality, but we make them smoother to make them look more realistic. But we also know that if you do that, then the contour lines are farther away from the original observation points. So I think this is a good example that shows that data that looks more realistic in visualization does not need to be that. Then the sixth challenge, also mentioned by Anders, is about data sharing and interoperability. So this is one of the fundamental issues that also have been addressed in the past, but it is still not solved. If you want to work with digital twins, then sharing data across domains, across sectors is still a challenge, and this becomes even more a prominent problem if more data and simulation models need to be shared and synchronized as we envision with digital twins. So it's partly about technical interoperability, like how can we integrate data from different domains, different scales, different temporal resolutions. And the technical interoperability also needs standards that are easy to use outside our domain to avoid lengthy preparation processes of the data so that people can use the data for the specific purpose. But there are also many non-technical aspects that need to be addressed if we really want to make the digital twin concept a reality. So, for example, this is about security, to avoid misuse of the data, about accountability, so to make sure that there are governments that are, or other organizations that are responsible to maintain the data and to update the data. It's about reliability, so what if there are errors in the data, who's reliable for that? It's about financing the data availability within available budgets. It's about copyright, and copyright is specifically a problem if we also expect companies to share data within a digital twin. So in the governmental sector, we are more or less used to share data among each other, and we have standards for this, we have data models for this, we have governance rules for this. But if you want companies to share their data also in an open environment, then this needs specific frameworks, and we still have to learn how that works, and also to make sure that the interests of companies are also covered. It's about privacy, to protect our personal data, and also about ethics, to assure appropriate use of the data. So all these aspects still need attention. Then about the last challenge, and I think this one is also very often overlooked. That's about the practice readiness of digital twins. So we have seen very nice outcomes of pilots, specific projects, big cities that show their very nice examples about digital twin implementation. But if we want to make sure that digital twins solutions do not only work on one specific area, a test area, or within a project, but want to assure that it also works after 10 years and also that it evolves, like Anders also explained, we have to pay attention to more fundamental issues. And I would like to show this via the Gartner's hype cycle. I don't know if you know this cycle graph, but it shows how a new technology, the time path of a new technology, how that goes, what the path is from introduction of the technology until it has been implemented in practice and has achieved a plateau of productivity where it's actually implemented in such a way that it does solve the problems that we have in reality, like climate adaptation and energy transition. And also within the budgets that are available for this. So if we look at digital twins, then we see that it has caused an innovation trigger here at the start. Then there was, I think, more or less 7-8 years ago, at least in the urban domain. At least when it was mentioned for the first time. Of course, there were similar challenges before. And those, then a lot of researchers and pilots have shown what you can do with digital twins. So the promises it gave to us. And there you see that I think that's also very good, that you see what the technical potentials are of a digital twin. But it also has led to a peak of inflated expectations. Because, if you work in a pilot, you can ignore maybe the nasty problems a bit. So after pilots, after they implement it in practice, then you see that it's to be a bit more difficult if you want to implement a pilot in practice. And then, there has been now awareness about of the technical and non-technical limitation of digital twins. And this, from this we should learn, and to see how the digital twin techniques that we have available, how they can evolve to a plateau of productivity, so that we can use the digital twins in a way that it does serve our data needs. So for this we have to understand how the implementation in practice can reach this plateau of productivity. And for this, we need to focus on realistic implementations. So not only strive for the highest level of detail, but maybe see first what is already available. And we also have to see, what are the budgets that are available, and to make this fit to each other, so that the implementations are realistic, and not only now because we have a project funded, but also in years after the project has been finalized. And if you talk about digital twins implementation in practice, it's also very important that there are agreements in place between the many different stakeholders, the different processes, different governments, different sectors, about sharing data and keeping the data up to date, about the accountability of the data. So, come to my conclusion. So the question was, digital twin, is it a comprehensive solution for that can solve all our problems that we face? We have very many global challenges to solve, or is it a too promising concept? Well, I think it's not a black or white answer. It's not yes and no. I think digital twin is very, very promising technology, but we have to be aware of the pitfalls and maybe the limitations also of the implementation if you want to implement it in practice. So firstly, I also would like to emphasize the strong metaphor of what a digital twin is. And I think we should embrace this. So maybe my story was a bit demotivating, but I think it's also nice to see that with this metaphor we can show what the geospatial domain and can offer to the digital twin technology, because we have addressed similar issues before. We did not solve them all, but the location aspect of digital twin is very prominent, and I think the geospatial sector has a lot to offer there. So I think we should embrace the concept to show what geospatial data is and what it can offer. But if we want to make digital twin a comprehensive solution, so more than a promising concept, we also should still solve the remaining and the fundamental problems, like developing infrastructures that can integrate data across different domains, different sectors, different governmental organizations, and it can also share data from companies. And then, last thing, as I think that's very important, that we should treat data and geospatial data as an asset in itself. So we should assure that data is maintained, it's clear that who's responsible for the data, that the finances are organized, that the governance is organized, that data between different governmental organizations are aligned, of course we don't start from scratch. There is already so much data available, and I would like to mention an example in the Netherlands. So in my group in Delft, we have reconstructed 3D models of all buildings of the Netherlands, and we could do that because we have open data as a principle of our policy in the Netherlands. And these data was reconstructed from the building footprints and a LiDAR data set, and we also have updated versions available of this LOD2 data set. And we publish it as open data, and it's adopted by many governmental organizations. It's nationwide available, and if you look at the wide use of this data, then I think this shows that it's a nice step to first start with what's already there, and that you can enrich this data, you can adapt the data to specific applications. So for example, there's a version of this data available that can be that can serve as input for computer fluid dynamic modeling, important for heat stress simulations, and so on. So thank you for your attention.
Thank you very much, Jantien. That was fascinating. And we'll be calling you back for questions later, if that's okay. Very interesting to hear.